So today we're going to kind of summarize everything we've been working on with regards to exponents. And yes, I'm sitting in my car doing this because everything is weird right now. Anyway, we're going to make sure you're clear on what positive, zero, and negative exponents are, and then look at the shortcuts to simplify. So now we're looking at a table that most of you had a chance to fill out the other day. Just want to make sure that everyone's clear on it, particularly people who were not in class the other day. We are looking at the positive exponents, the idea that 1 times 2 to the 2 to the third power is 1 times 2 times 2 times 2, which is a value of 8. And 1 times 2 times 2 is 2 squared, value of 4. We're getting to the idea of what are positive and negative and zero exponents mean. And one of the ways I'd like you to think about that is to look at this table and recognize that going from here to here, from 2 to the third down to 2 to the second is the same as dividing by 2. And if we're looking at that pattern continuing, dividing by 2, then 1 times 2 to the 0 would have to just be 1 times 1, which is a value of 1. Continuing dividing by 2, moving in that direction, this would be 1 divided by 2, and that value is 1/2. And this would be 1 divided by 2 twice, which is 1 divided by 2 times 2, which is 1/4. And this would then be 1 divided by 2 to the third, which is 1 over 2 times 2 times 2. I don't have my pen, can you tell? And that's 1/8. So a negative exponent means to divide. And I'm going to show that on the next slide as well. So just to clarify, a positive exponent, like these, positive exponents mean to multiply. Zero exponent just equals 1. The whole thing turns into 1 because you're not doing anything to that base. You're not multiplying it by itself. You're not dividing it by itself. It's just that invisible 1 times 1. And then the last one is a negative exponent. And a negative exponent, actually, I have to get rid of all of this mess here. A negative exponent down here, negative exponents mean two things, or you can think about it 2 ways. One is to divide by the base as many times as the exponent says, or you can talk about the reciprocal or flipping it. That's not working. Reciprocal to the positive power. Notice that 1 times 2 to the negative 1 is the same thing as 1 over 2 to the first. 2 to the negative 2 is the same thing as 1 divided by 2 squared. 2 to the negative 3, 1 divided by 2 to the third. So it's a flipping type of thing. Here are all of our shortcuts, and I'm just going to kind of repeat each one. You probably have already figured it out yourself. If they have the same base, x to the 7th times x to the 5th, for example, that's the same as x times x times x times x 7 times, x times 5 times. Add them all together, you'd end up with x to the 12th. So when you're multiplying exponents with the same base, you can just go ahead and keep that base. The base doesn't change, and add the exponents. When you're dividing, like x to the 7th divided by x to the 5th, you'd have x 7 times multiplied by itself up top, and x multiplied by itself 5 times in the bottom, and you would divide out all those giant ones, and you'd end up with x squared as your, I don't like that when I put in green, x squared over 1, or just x squared. You're going to keep that base and subtract the exponents. when you have something in parentheses, a power that's been carried to a power, it's like the same thing as this particular base is multiplied by itself 4 times. It would be like 2x to the third times 2x to the third times 2x to the third times 2x to the third, which is 2 times 2 times 2 times 2, or 2 to the 4th power. This is hard to read. 2 to the 4th power. And x to the third, 3, 6, 9, 12, which is the same thing as 3 times 4 is 12. So we're going to go ahead and distribute the exponents to all parts of that base. And then we just talked a little about a 0 exponent, but all numbers to the 0 power equal 1. The whole thing becomes 1, except 0, because 0 is a weirdo. No offense, 0. Negative exponents, once again, means to divide by the base to the positive power. So x to the negative 2 is the same thing as 1 divided by x squared, or you can think about x over 1 as the base, and then flip it to 1 over x squared, reciprocal of the base to the positive power. We're going to spend a lot of time on that, but just really be thoughtful and slow about it, and don't assume it means something else. It means division, or reciprocal to the positive power. And then what if you have numbers and variables? Deal with the numbers like you've been dealing with them for forever. So for example, if I were going to deal with this one, I'm going to deal with the numbers the same way we'd always deal with the fraction. That's 2 divided by 8, or 1/4. And x to the 5th divided by x to the 3rd, which we just talked about. Then there you've got the same base. You can subtract the exponents. X to the 2nd, so it'd be 1 over 4. And then x to the 2nd would be on top. The inside, actually this is the example on the inside, so you can go ahead and look at your answers when you get to that one. So I'm just going to quickly show you each of these so it's easier to read. There's the answers to A, x to the 5th, y to the 3rd. Notice this guy has a invisible 1. And then x to the 4th, x to the 12th is the same thing as x to the 16th. If we are dividing, 65 minus 60 is x to the 5th. But then be real careful in the second example. There's y squared up top and y to the bottom, which is why the y is up top. But there's more x's on the bottom, so that's why it's x to the 67th. If you have y times x to the negative 67th, it's not simplified until you get rid of that negative. So you might as well just go think about it in terms of where that x is going to stay. In this case, we always want to deal with the getting rid of the negative as well. Power to a power, x to the 12th, x to the 6th, y to the 3rd. The 2 is part of the base in the third one, so you do have to do 2 to the 3rd, or 8. X to the 9th, that's hard to read. And then y to the 6th. 0 exponents, 1 times x to the 5th, 36 times 1, which is 36, and 10 to the 0 is 1. We're going to do set B in class in either Tuesday or Wednesday. So if you already did it, then I'll give you the answers tomorrow or the next day or whatever. Negative exponents. 1/5 is the base to the negative 2 power. So we're going to use the reciprocal, flip it to the positive power. So 5 squared would be 5 times 5, which is 25. The second one, 2x, is the base, so we're going to divide by 2x 3 times. 1 divided by 2x times 2x times 2x, which would be 8x to the 3rd power. And then the last one was the examples on the other side. Notice in this example right here that it's 1/4 is a fraction, and then there's more x's on top, so it's x squared. Here the 6 times 5 is 30, and x squared times x to the 3rd is x to the 5th. So simplifying means you want to get rid of the negatives. Simplifying exponents mean divide out all the common factors if you're dividing. That's not going to work. I'll just say it and tell you later to take those notes. Divide out the common factors. You can't leave any zeros or negative exponents, and zeros need to be taken care of. So if it says x to the 0, it has to be rewritten as 1. If it says x to the negative 4, you have to rewrite it as 1 divided by x to the positive 4. It's only allowed to have positive exponents in a simplified answer. And then when you multiply or divide, you're going to just make sure that all common bases have been combined or canceled out. There you go. Hope all is well.